Hey everyone, let's learn how to tackle this educator problem, unique number. So in this problem, you're given a number and you'd like to know if all of the digits in the number are unique. So for instance, this 1, 2, 3, 4, you have 1, 2, 3, 4, all unique, you return true. In this input, you have 1, 2, 3, and then 1 again. Since 1's there twice, you return false. Not all the digits are unique. Now, if you had watched, I think it was the last video about hashing mode. In that video, we used a map to count the number of occurrences of each digit, or of each number in an array. And you can imagine we can do a similar thing here, right? Or we can count using a map how many times each digit occurs, and then with iterate through that map and make sure that all of the digits in the map take a count of 1. That's not the case, then we return false. But there's actually, I think, a little bit of a simpler approach. It's a little bit more elegant as well. And to conceptualize this approach, we first have to remember that sets only take unique values, right? So let's talk about what would happen if, say, for this problem, we push each of the digits into a set. Well, first we would push in 1, for the set, push in 2, push in 3, and push in 4. Looks good. We have a set with all 4 digits in it. All right. What about the simple input 2 here? Well, first we push in 1, we push in 2, push in 3. When we get to this last one, we try to push it in again. Nothing happens. 1's already in the set. This is the final set. Now, what you might notice is that here we only have 3 elements in the set, and that's because there was a duplicate in the original input. So here, when all 4 of the digits are unique, the 4 pushes to the set all add an element to the set. But here, when the 4 digits have an overlap, that 1 digit that overlaps doesn't contribute to a value in the set. Only 3 times will a new value be pushed into a set. So therefore, here, the size of this set equals the size of this number. And here, the size of the set is less than this number, or at least the number of digits of this number. And that's really all we need to know in order to start this question. So let's create a unordered set. This will store integers, right? The digits we've seen so far in the number. And we can just call this digits. Now, this brings us to another problem. So we have an integer. And if we try to loop over the integer, right? If I say, all right, loop over 1, 2, 3, 4, the code might just, I don't know, give us a range from 0 to 1, 2, 3, 4. It doesn't, how do we extract the digits, right? One way to do this, which you may have seen before, is say we're given a number like 1, 2, 3, 4. If we mod by 10, what is this number mod by 10? It's just 4, right? So modding by 10 will always extract that number in the 1's place. So we can mod by 10 to get that last digit. Here we push it into the set, and then we divide by 10. So 1, 2, 3, 4, divide by 10 and floor, so integer division. It will just give us 1, 2, 3. So then if we mod this by 10, we get 3, that last digit. Divide by 10, we knock off the 3, we just get 12. Mod by 10, we get the 2 off. Divide by 10, we just get 1. That's our last value we get by modding by 10. And then we divide by 10, we end up with 0. So you can see by repeated modulation and division by 10, we can grab the number digit by digit. But again, in keeping with the theme of how we want to solve this problem, there's a much simpler way. And that's simply just to cast this int n to a string. So we can say like string s is equal to toString n. and that will turn this 1, 2, 3, 4 number to a string of characters 1, then 2, then 3, then 4. So there we can iterate over character by character, which just is more suited to what we want to do here. Now, we're no longer pushing in digits as integers, we're pushing them in as characters. So let's update our set. And then let's iterate over the string. Now here we can actually use a range-based for loop like so, just to make things a little easier. So for each individual character C existing in S, this is the same thing as just doing like a for, I equals 0 to I equals S dot size. This will just be equal to like SI at each iteration. Right? We're extracting each character out one by one. So again, like I said, we'll push each character. We do an insert actually into the set. And then at the very end, we can return true if the lengths of the set, like this 1, 2, 3, 4, and the original string, like this 1, 2, 3, 4, are the same. Otherwise, we return false. So you might think initially like, oh, if S dot size is equal to S dot size, true, true, else return false. And that might work, but there's a little bit of a nicer way to do this. And that's by recognizing that here, we're saying if this condition returns true, we return true. And if this condition returns false, we return false. So we can kind of cut out the middleman and straight up just return this condition itself, right? If this value is true, we return true, right? Sizes are the same, wonderful. If the sizes are not the same, we return false, and this is equal to false. So you can see that this gives us the exact same output. And if we submit, we pass all the test cases. All right, so hopefully that was helpful. If you have any questions, feel free to reach out to any of the TAs on Slack. And I'll see you in the next video.